Okay, Manal, you are done? Manal,
Yes, ma'am, but I have a few doubts.
yes, tell me.
Ma'am, when is work said to be positive and negative?
Okay, see, when, for example, this is the object, right? You are putting your force in this direction, right? And this object is also moving in this direction. So this is a positive work. Okay. But for example, over here, for example, something is falling from here, right? And you are here and you are pushing it. So you are putting your force this side, but this object is moving down, right? So that is a negative. When the direction of force and the motion of the object is opposite, right? They are not in the same direction, that is negative work. But if they are moving in the same direction, right, that is a positive work. Clear?
Yes, ma'am.
Hmm.
Ma'am, how do we calculate positive and negative energy? Ma'am.
You don't have to calculate anything. It's basically, it is showing you, like you will have the question, right? Over there, for example, like whatever question is given to you, if your answer comes in negative, that is a negative work is done, right? But in case if your answer comes in a positive, then it is a positive work. Clear? So you don't have to calculate. There is no formula to calculate negative and positive differently. We have the same formula only. But whatever answer comes, that will determine whether the work is done is negative or positive. Okay?
Yes, ma'am.
Hmm. And
And ma'am, in page number 148, ma'am, I'm having doubts in example 11.2.
this one, numerical?
Ma'am,
This one,
11
numerical,
point.
right? Don't worry,
Yes, ma'am.
numerical we'll discuss in the next class. Don't worry about that. Numericals we have to discuss from basics. It's not like randomly you will put the words. We will first discuss all the formulas of the chapter, then step by step we will do it. Don't worry.
Okay,
Okay?
ma'am. Okay, ma'am. Ma'am, and ma'am, most of the doubts were in the numericals itself, ma'am.
Okay. Others, I think, okay. So now we'll just do the question answers, right? So after that, you will get to know more about it. Clear?
Okay, ma'am.
So now listen to it very carefully. So first of all, look at the activities listed below. Reason out whether or not work is done in the light of understanding of term work. Right? First of all, Suma is swimming in a pond. Right? So over here, these are the things which just accordingly think yourself. You know what is work. You have two situations. Right? So just in your notebook write yes, no, yes, no. Then we will discuss whether you were right or wrong. Okay?
Okay, ma'am.
Quickly.
Yes, ma'am, I'm done.
Okay, so now let's just discuss it one by one. First of all, is Suma is swimming in a pond. So what do you think? This is a work done or not?
Yes, ma'am.
Okay. So over here, Suma is applying the force, right? And his direction is moving. She is moving from this place to this. So therefore, the work is done. Second is a donkey is carrying a load on its back.
No, ma'am. No work is done.
No
Because
work.
he's
Yes.
not.
Work done by the donkey is zero because
Yes, ma'am.
donkey is carrying it but not moving, right?
Yes, ma'am.
Next is a windmill is lifting water from a well.
Yes, ma'am. Work is done.
Why? Work is done against the gravity, right?
Yes.
Because it is lifting the water from here to here. Then a green plant is carrying out the photosynthesis.
No work is done.
Yeah, because not moving nothing. Then an engine is pulling a train.
Work is done.
Engine is wait. See, an engine is pulling a train. Fifth one. Tell me.
My work is done.
Yes. Next, Drying of food grains.
No. Okay, sir.
Wind energy applies a force. The sailboat.
Okay, sir.
Very good. I hope now it's clear to you.
Yes,
Right?
ma'am.
This is a numerical. We'll leave it. Then this. A battery lights a bulb. Describe the energy change involved in the process. Because of the battery, what is happening? The bulb is glowing. Right? So when a bulb is converted to a battery, the battery has chemical energy which is converted into the electric energy. Right? This electric energy provided to the bulb further converted into light energy and the heat energy. Right? So chemical energy is being converted into electric energy and the light energy plus heat energy. Clear?
Yes, ma'am.
Then next one is the potential energy of a free falling object decreases progressively. Does this violate the law of conservation of mass? You said in the law of conservation of mass, energy cannot be created, not destroyed. But as you know, the potential energy of the object goes on falling once it is falling downward, right? So over here, what does it mean? Does this violate the law of conservation of energy? See, it is true that the potential energy of free falling object decreases progressively, but as the object falls, its speed increases progressively, right? That is, the kinetic energy of the object increases progressively. Kinetic energy will increase with increase in the speed. Now we can see that law of conservation of energy is not violated because the decrease in potential energy result in increase of kinetic energy and the total mechanical energy of the body remain conserved. See, I have already explained you the relation between the height and the this potential energy and kinetic energy, right? So if you are falling, if this object is falling down, potential energy will be also falling, right? For example, the potential energy was 10. Now here it will be 7, 6, whatever it is. Okay. But for kinetic energy, for example, the potential energy was 7 over here, right? For the kinetic energy is 7. Now it will be 10. Clear?
Yes, ma'am.
So over here, see, though your potential energy is decreasing, but kinetic energy is increasing. So whatever your potential energy is losing, kinetic energy is covering that, right? So that's why we can say that no, we are not violating law of conservation of energy, right?
Yes, ma'am.
Earlier your energy was 17. Here also you have 17, right? So it is not being violated. You cannot create it nor you can destroy it. Okay.
Yes, ma'am.
Then why are the various energy transformation that occur when you are riding a bicycle? So see, when we are riding a bicycle, we are converting our muscular energy into rotational kinetic energy of the pedal of the bicycle, which is transformed to the wheels. Due to this, the bicycle wheels move forward. And due to the movement of the bicycle as well as the person riding the bicycle both have the kinetic energy, right? So you know you are putting a pressure on the pedals, right? That are creating the energy over there. And once you have the energy, you will move forward. That's why the bicycle, nobody is pushing you, but still you are able to, move the bicycle, right? So why? Because the person riding the bicycle plus the bicycle, they have the kinetic energy and they increases with increase in speed, right? So that's why the kinetic energy is increasing as your speed of the bicycle is increasing. Clear?
Yes, ma'am.
Now, does the transfer of energy take place when you push a huge rock with all your might and fail to move it? Where is the energy you spent going? When we push a huge rock and fail to move it, the energy spent by us produces heat in our body. The produced heat is dissipated to the atmosphere. Okay, so where the energy is going, that is going to the atmosphere. This is you have to remember. Okay, because see, for example, over here, this is a cup of tea, right? This is a you can say beaker. From this beaker you are pouring the tea here. Maybe some of the tea will be falling down, right? So that tea is going to you know go into the atmosphere, not in the cup. Clear? So similarly, when we transfer energy from one object to another, most of the energy you spend, it's go where? In the atmosphere. Clear?
Yes, ma'am.
Now these are numerical. Then what is work done by the force of gravity on the satellite moving around the earth? Very important question. For example, this is the earth and you have the satellites over there, right? These are the satellites. So gravity pulls everything toward it, right? But why gravity is not pulling this satellite and they are coming to earth, right? So we know that in case of circular motion, the direction of force is always perpendicular to its displacement. When a force is perpendicular, perpendicular means for example, the object is falling here, it will form a 90 degree, right? When a force is perpendicular to the displacement, then no work is done. When a satellite moves around the Earth, then at each point of its circular path, the direction of the force of gravity on the satellite, which is along the radius, is perpendicular to the direction of displacement along a tangent. Hence, the work done on the satellite by the force of the gravity is zero. Is it clear?
Yes, ma'am.
Then, can there be displacement of an object in absence of any force acting on it? Discuss this question with your friends and teacher. See, displacement in an object can be zero if no force is being acting over here. Why? Because you are here, I'm not putting any force, so you will be here only. So that means you are not moving. It can be zero, right? So
Yes,
yes,
ma'am.
displacement of an object is possible without any force, as this is possible when the object is under uniform motion along a straight line, right? So for example, this is a slanting here. You are not putting any force, but still that is moving, right? So at that time, force is zero, and force is mass into acceleration. That will be zero. Clear? So
Okay, ma'am.
in two situations, it can be first that object is not moving, displacement will be zero. Again, for example, over here you put it something, right? Now this object is moving. You are not putting any force, but still this object is moving, right? At that time also, then it will come back to here only. So that's, ma'am, the object is either in the state of rest, right, or moving with a constant velocity or uniform motion along a straight line, right? So you have two situations. One, if you are at stress, then also your displacement will be zero. If the object is moving with constant velocity, constant speed, then also it displacement will be zero. Is it clear?
Yes, ma'am.
Okay. Now, a person holds a bundle of hay over his head for 30 minutes and gets tired. Has the work done or not? This you know, right? Hay means you can say a bundle of you crop and all that, right? So that is a hay. So when a person holds a bundle of hay over his head for 30 minutes and get tired, in this case, bundle is not moving. Hence, displacement is zero. So you can say that work done is zero, right?
Yes, ma'am.
Hmm. Then coming to next one, this is basically not that much important. Just leave it. This an object of mass m. This is also numerical, so leave it. Then this one. Sony says that the acceleration in an object could be zero even when several forces are acting on it. Do you agree with her? Yes or no? Okay. So when the net force of all the forces acting on an object is zero, the acceleration of the object can be zero. Yes. Clear?
Yes, ma'am.
Hmm. Now this you have to find this one. A freely falling object eventually stops on reaching the ground. What happens to its kinetic energy? You know this, right? So before hitting the ground, the object has a kinetic energy, and when the object hits hard the ground, its kinetic energy get converted into first the potential energy of the configuration of a body and the ground object, and the ground get deformed a little bit at the point of collision. For example, you threw a ball. So this is a ground. If you will throw it, it will recently move like this. A gap will be there, right? Second, you will that energy will be converted into sound energy, right? Because you once something falls, you get a sound, right? So
Yes, ma'am.
this. Then next, heat energy. Over here, it will be little warm because it's moving from so long. You know that will have a heat energy as well. Clear?
Yes, ma'am.
Okay. So now this is basically the theory part. This is what you have to remember. If you know the relation between all the things, you can easily write any question, right?
Yes,
So
ma'am.
now, one by one, what you will be doing, you will be, what you are going to do, you are going to read it one by one, right? And then, like whatever question we discussed, you read it. And after that, I'll be leaving you. Tomorrow, we'll be doing the numericals. Okay?
Okay, ma'am.
Wait a minute. Yeah, read this.
Yes, ma'am. I'm done. Yes, ma'am, I'm done. Ma'am, I'm done. Ma'am, I'm done. Yes, ma'am, I'm done. Yes, ma'am, I'm done.